Hello students, I am Dr. Jamana presenting for you for a BSc first sem general chemistry paper. The topic I am going to discuss now is purification of organic compounds by distillation and steam distillation. Purification means already you may be knowing about this. Purification means it is the removal of unwanted impurities present in an compound, in an organic compound, or it means isolation or separation of compound of our interest from other impurities. A large number of methods are available for the purification of substances. Already you may be familiar with some of the methods like crystallization, fractional crystallization, distillation, fractional distillation, steam distillation, distillation under reduced pressure, sublimation, etc. The choice of method, however, depends upon the nature of the substance which you want to separate. It may be solid or it may be liquid. It also depends upon the type of impurities present in it. So some prerequisites. So you should know when you go for separation, by choosing particular method, you should know the nature of the substance, whether it is solid or liquid. And also properties of the compounds such as vapor pressure, boiling point, solubility of the compound which you want to separate, you should know from the literature. Let us go in detail about distillation. The principle behind this is the mixture of liquids can be separated by distillation when there is a difference in their boiling points. So this method is suitable for mixture of liquids, not mixture of solids. Those liquids should differ in their boiling points. The boiling point is the temperature at which the vapor pressure of the liquid equals atmospheric pressure. When you start heating liquid, there exists above this vapor. So these vapors exert some pressure, what we call it as vapor pressure. So when you start heating, vapor pressure equals atmospheric pressure at a particular temperature. That temperature is the boiling point of that liquid. This method separates volatile liquids from non-volatile liquids. So this is an experimental setup for distillation. Even from 3rd, 4th standard already you might have studied. Batti ilisuvike, in Kannada we call it as. This is the simple distillation setup. Just recall your middle school or high school. From that onwards you might have studied about this. This is the round bottom flask where we are going to fill mixture of liquids. Below which you find Bunsen burner. This is fitted with a stand. At the mouth, we are going to fix thermometer with cork. It has side arm through which condenser is fixed. So condenser has 2 outlets. One is water outlet and another one is water inlet. So here the tube is connected to the tap where water is made to run over the condenser. As a result, always the condenser is kept cool. This is also fitted with a stand. You have a receiver here. That is nothing but flask. You can keep at the bottom or you can fit with a stand. And these two are connected with a bent tube, right? So this is about the setup for a distillation. Let us see the procedure. Already I have explained with the picture. The mixture is taken in the round bottom flask, which is boiled. The more volatile component with lower boiling point starts evaporating first, and it is collected in a separate container. So when you start heating, the more volatile one with less boiling point start moving up as vapor. When it passes through this side tube, when it reaches condenser, it condenses into liquid and it falls into this receiver. A condenser is used to hasten the process of condensation. So the condenser is facilitated to condense the vapor which is evaporated. For example, Say if you have a mixture of chloroform and aniline to be separated by distillation, you should know that chloroform is having 60 degrees Celsius as its boiling point, whereas aniline is very high, that is 189 degrees Celsius. So the two boiling points are very much different. As a result, by this method, we can easily separate aniline as well as chloroform. So similarly, now let us pass on to this steam distillation. So one more method under distillation. Then what is the principle behind this method? When steam is passed into the flask containing the compound to be purified, the compound starts to boil at a temperature at which some of the vapor pressure of the liquid and that of the water, what we call it as aqueous tension, it becomes equal to the atmospheric pressure. So when steam is considered here, the atmospheric pressure equals sum of the vapor pressure of liquid as well as that of the water. At that temperature, the compound starts boiling. So this allows the compound to vaporize along with the water at a temperature below its normal boiling point, leaving behind the impurities. So please remember, in steam distillation, when we start boiling under steam, that is passing through the steam, the liquid starts boiling very much below its boiling point. When it starts boiling very much below its boiling point, as a result, the compound present in your solvent will not undergo degradation. That you should remember. So here, it's not the boiling point, it is the compound starts boiling at a temperature when some of that is the vapor pressure of the liquid and that of the water should equals atmospheric pressure. So always that boils when pressure of the liquid and that of the aqueous tension equals atmospheric pressure at a particular temperature. This temperature is much below its boiling point. As a result, the compound which is present in your liquid will not undergo degradation. Then the compound is called steam volatile. As the compound is immiscible with the water, it makes a separate layer on condensation and it can be separated. This sentence I will make you understand by using this experimental setup. You can observe here, already you have come across this setup with distillation unit. Now, this distillation unit, through the glass tube, we are going to connect for another round bottom flask. Okay, so in which this in turn it is connected to the condenser and you have receiver here. Here you have Bunsen burner. This is the round bottom flask fitted with the temperature that is yes, it is the temperature, thermometer. I'm sorry, it is thermometer. So when it starts boiling, mixture of liquids, right? Sorry, I'm very sorry. It is water you have taken here for the generation of steam here. The generated steam is passed here, right? Here you have a mixture of liquid or the compound is present in your mixture of liquids, right? So what you can do is you can start heating, boiling. Steam enters here. I'm sorry, this is not the thermometer, it is the safety tube, because here when the steam is excess, it is made to come out through this. So hence it is called safety tube. It is not the thermometer, I'm sorry. So here you have compound present in your mixture of the liquids. Okay, if it is required, you can boil it. If it is not required, you need not use this. That's why I have shown in the circle here. So when steam is passed, the liquid starts boiling here. When vapor pressure plus aqueous tension equals atmospheric pressure, then the steam volatile compound passes through this, condenses here and falls in this. So here you can see the two layers. steam which has come in the form of water, and this is the distilled liquid. Suppose if you find it is difficult to separate these two layers by separating funnel, what you can do is you can add little more organic solvent to this, so the volume increases, then you can separate them. Steam volatile component vaporizes and gets collected along with the water. Immiscible liquid and water layers you can see. I have shown already. Organic solvent is added in which organic compound is soluble. Solvent containing compound and water are separated. Organic solvent evaporated to get pure organic compound. I'm sorry. This method is also employed for the extraction of organic compound from natural source. So as an example, essential oil is extracted from plant source by steam distillation. So these are the references I made. So this is the more useful textbook for you. This is Digital Learning, Department of Collegiate Education is presenting you these videos. Thank you very much.